today is we are going to get through these notes, and then we have an assignment at the end. Okay, boys? I'm about to separate you guys if y'all can't stay quiet. So, last week we talked a lot about counting atoms. Okay, we did it all week last week. That way we had a good background for what we're going to be learning this week. Okay, this week kind of takes it a step further with balancing compounds and equations. But if you understand counting atoms from last week, then you're already in a good spot to be ahead on this next little topic that we're covering. Okay? Like what was mentioned in the warm-up, we're going to be extending that thought about law of conservation of matter says that matter cannot be created or destroyed. Okay? So with that being said, we got to figure out if I have 4 hydrogens that I started with in my reaction, I always have to end with at least 4 hydrogens too. Okay? I can't just have more or less. So I'm going to figure out how to balance those. That way I am conserving that matter and things like that. So let's fill out these notes and then let's start working out some balancing problems. Okay? Let me zoom in a little bit. Can y'all see that okay? Alright, so chemical equation is our first 2 words. A chemical equation is a way of writing out a chemical reaction. The arrow in the equation means a reaction is happening. Okay, so you have seen a chemical reaction or a chemical equation before. I'm going to write an example out here. Like if I have H2 plus O2 makes H2O. Okay, that's a chemical equation.
Wait, how did it? What is that about?
What? We're going to figure that out later. Okay, so what that second bullet point saying is that the arrow in the equation means a reaction is happening. So I have hydrogen and oxygen. Something happens in this arrow and it makes H2O. Okay, so this arrow is just a symbol for showing a chemical reaction is going to happen or has happened. All right, next bullet point. The law of conservation of matter. States that matter cannot be created nor destroyed. Okay, we know that already. We've heard that time and time again. Okay, what's important for us in the law of conservation of matter is this next bullet point. So I'm going to put a star by it. This next one that we're going to go over. So speaking about the law of conservation of matter, this is also true for equations. It means that the number of atoms in an element must be equal on both sides of an equation. Underline that part for me. Must be equal on both sides of an equation. In other words, the equation must be balanced. Okay, so in an equation, we have reactants. Reactants, yes, on the left side, and products on the right side. We're going to see what this looks like in just a second. Reactants go on the left-hand side, products go on the right-hand side. Okay, so right here in our example it says circle the reactants. What am I going to circle?
C plus O2.
C plus O2. So this right here is my reactants. What would CO2 be on the right-hand side? Yes, I'm going to put a box around that. That is called the product, what was made. Okay, and then we're going to add got another word here. We have reactants on the left, products on the right. Okay, we've talked about how this arrow means that a reaction is happening. Sometimes whenever I read an equation, I would say carbon plus oxygen yields carbon dioxide. So we're going to write yields underneath that arrow because sometimes it's called yields. Y-I-E-L-D-S with quotes around it. Carbon plus oxygen yields carbon dioxide. Okay, so if you hear the word yield, you know that it's the arrow in the equation. Okay, that's just kind of another vocab word for you to know. Okay, this is kind of throwback, this next section. Each chemical formula has 3 parts. Last week, what did we call the big numbers in front? Coefficients. That is going to be that number 1 right there. Let me make sure I'm on the screen. There we go. So number 1 is a coefficient. The larger number in front of the element symbol. What were the small numbers? Subscript. The smaller number that is behind the element symbol. And then I do have the symbol, a letter representing an element from the periodic table. So we have coefficient, subscripts, and a symbol. Alright, so before we get into balancing, let's talk about how down here, in both situations, in this 2H and in that H2, how many hydrogens do I have? 2. Okay? But they mean something different. Alright? Or else they'd be written the same. So what does 2H mean? Yes. Okay? So if I were to draw this one out, I would have 2 hydrogens that are not touching. Okay? So this is 2 separate hydrogen molecules. What would H2 look like?
Like 1 circle with 2 H's.
Yes. So I'm going to draw it like this, but they're touching. So now I have 1 molecule of 2 hydrogen atoms bonded. Okay, so this is going to play a part in balancing if you're a visual person, being able to see what these are supposed to look like. Is everybody okay with the front page? Alright, let's flip it over to the back. Let's label this at the top really quick. What are these big numbers called? Coefficients. What is this left side of the reaction called? Reactants. What's another word for the arrow? Yields. And what did I make over here? What's it called? A product, yes. And what's that small number? Subscript. Okay, so there will be test questions that kind of look like this, where there's parts of the equation, and there's a blank for you to fill in, and you have to label the different parts. Okay, coefficient, subscripts, yields, reactants, and products. Okay, I need you to make this bullet point like super obvious on your paper. Like box it, put 5,000 stars around it. Okay, it's going to be a big deal when we balance equations. So it says the golden rule: always change the coefficient never change the subscript. And we're going to see what that means in a second. But make sure that you understand that. Okay? Whenever I balance an equation, I can never change those little numbers. Okay? Those little numbers are permanent. What I can change are the big numbers in front, those coefficients. Okay? That's the golden rule of balancing equations. Alright, so what I want to do on this next part is I'm going to actually get up on the board and write this out. But as I do it, I'm going to change marker colors and things like that. Maybe. I'm not going to be able to get it small enough. Okay, so what I'm going to do is, as I do step 1 up here, I'm going to write it on our example down here. Okay? One thing I need to point out is that these are subscripts because they're behind them. I just forgot to make them littler. Okay, so this is a subscript, and that 2 right there is also a subscript. Alright? Don't get confused on that. So, step 1 for balancing equations, make a list of all the elements. Make a list of all the elements on both sides. Make a list of all the elements on both sides. Okay, so what that's going to look like, whenever I say sides, I mean reactants versus products. Okay? So, what I like to do whenever I balance an equation is I draw a line down my arrow, and that separates my sides for me. Okay? So, what elements do we have for the reactants? Hydrogen and oxygen. So, I'm just going to make a list. H and O. Okay? And it should be the same on my products because of the whole conservation of matter thing. If I have hydrogen and oxygen on my reactants, I'm not going to randomly get a magnesium on my products. Okay? So my list that I make should be identical on both sides. So I know that's true, H and O. So here's my list on my product side, H and O. Alright, second step. Count how many of each element you have. Count how many of each element you have. Okay, and you're going to do this on both sides. Okay, maybe we should add that. For both sides. Okay, so this goes back to last week. Okay, I've prepared you for this. We are ready. How many hydrogens do I have on my reactants? 2. So I'm just going to put a 2 next to hydrogen. What about oxygen? 2. Okay? I'm going to do the same thing on my product side. How many hydrogen do I have in my products? 2. And what about oxygen? 1. Okay, step 3. Check to see if your equation is balanced. So how I want to do this is I'm going to ask myself, so I'm going to put this part in quotations. Are all my numbers the same on both sides? That's a question I'm going to ask myself. Are all my numbers the same on both sides? Okay, so are my hydrogens the same on my reactants and products? Yes, there's both 2. What about oxygen? No. So that tells me that I got to balance it. Okay? I have 2 oxygens on my reactants, only 1 on my products, so something's not right. It's up to me to fix it because I can't lose matter. I can't just drop an oxygen and it be okay because of the law of conservation of matter. Okay? So when that happens, our step 4 is we are going to, let me erase that. Add coefficients to the equation until everything is balanced. Add coefficients to the equation until everything is balanced. Okay? Remember, this is when you cannot change the subscripts. Okay? So these subscripts that are here are permanent and I cannot change them. Alright? Because then I change the whole equation itself and the atom that it's talking about. What I can do is add big numbers in front to make it all balanced. Okay, so the worksheets that you'll be doing, they'll have blanks in front of all of these, and that's space for you to add your coefficients to. Okay, so when I go to balance this, I know my hydrogens are equal. I have 2 oxygens on this side. I got to find a way to get 2 oxygens on my products. How am I going to do that?
You put a code 2.
Okay, so I can only put a coefficient. I can't add a subscript over here.
But then that would make it
have
4.
Yep.
So what if you put it over here?
Okay, y'all are on the right track. Good job. So I have to put a 2 there to get this oxygen to 2. But what did I just change? I remember these coefficients affect everything. So now how many hydrogens do I have? 4. So I'm just going to mark out that 2. I have 4 hydrogens and I have 2 oxygens on that side now. Okay, now my hydrogens aren't balanced. What do I do?
You can put a 2 by the H.
Yeah, that's all, yeah.
Okay, if I put a 2 here, how many H's do I have now?
4.
And does that change my oxygen?
No.
No. Okay?
Separate right now.
So, yeah, on this side they're separate. So now I have 4 hydrogens, 2 oxygens. 4 hydrogens, 2 oxygens, I'm done. My equation is balanced. Okay? Y'all are going to have to do this part on your own eventually. That's the goal. Okay? So, what I want to do now is I'm going to put 2 examples on the board. And I want you to try to solve them. And then I'm going to give you the answers. And then we'll do our actual worksheet. Does that sound good? All right.
You just want us to solve them on the notes?
Yeah, I know you don't have a ton of room, but we're going to talk about it. Where'd my paper go? Here it is. Okay, the first one that I want you to solve is, we're going to talk through it as a class. I have SO2 plus O2 yields SO3. Okay, that's my reaction. I got to balance it. Okay, if you want to write this down on your paper, you can. That way you have an example. Okay? To do this, I got to take inventory first. So I'm going to draw a line through my arrow because that splits my sides. And I'm going to take inventory. How many S's do I have over here? How many oxygens?
2,
Plus
2,
2. So I have 4 total oxygen.
Yeah.
Okay, I'm going to make the same list. I want my S to be on top just like over here. I have 1. I have 3 oxygen on my product side. Okay, so this one gets weird whenever 3s are involved. Okay, 3s throw things off. But we're smart enough to catch it, and we know better than to get tricked by a 3. Okay, so what I would like to do is somehow get this oxygen to 4, right? But is there any way I can do that?
No.
If I put a 1 here, it's still 3. If I put a 2 here, it changes it to 6. You see that? I'm going to have to go with that 2. Okay, that's my next step. So, I put a 2 here. What numbers change?
The S and the T. I mean the O.
Okay, I have to change my S just like I have to change my O because that coefficient affects everything. So now I have 2 sulfurs, 6 oxygens. Over here, what the heck am I going to do? I have to balance it.
Oh wait.
Yeah, because they change both.
So I would look at my S first. Balance my S. How do I make this a 2?
Put a 2 in there.
I have to put a 2. So now I have 2 S's.
That would be good. Because then the 2 would just add up with the 4.
Yep. So I have 2 times 2 here for oxygen, which is 4.
And then add up the 2.
Another 2. I'm balanced. Okay? I'm good to go on that one. You'll see how that works? Sometimes you have to go back and forth like that. Okay? Let's do one more, and then I'm going to let you work on the worksheet on your own. Oh yeah. So P4 plus Cl2 yields PCl5. Okay, this one's kind of weird. There's a lot going on, but we're going to keep following those same steps. Let's take inventory. Jasmine, how many P's do I have? 4. Other Jasmine, how many chlorines do I have? 2, good. Ashley, take inventory for me on my products. How many P?
5.
Right here?
1.
1, good. How many Cl, Ashley?
5.
Yep, good job. Okay, this one's weird because I can't make this chlorine 5, right? I can't bring that one down to 2, so we're going to have to tinker with it a little bit. Okay? What I would like to do is let's look at our P's first. Okay? I have 4 on this side. How am I going to get 4 for my products?
You put 4 in that.
I'm going to have to put a 4 there, right? So if I put a 4 here, I now have 4 P's, but how many CLs do I have?
20.
20. Okay, my P's are good. How do I get chlorine to 20?
You put 10.
Put a 10. Okay, that's a big number, but it works. So don't freak out if you get a big number. That's why I did this example. Okay? Everybody good with this? Kind of. For the most part. All right, I'm going to pass out your worksheet. And if you need help on it,